making another video. Yeah, the other comment video just went on and on. Anyway, so I wanted to do some real physics. So I thought I'd explain some of this, the idea of a exchange of direction. And so this being critical, like there's no energy transfer, there's just information transferred, and the information is in direction. So this is sort of consistent with some of the things Susskind and other people talk about, but obviously I'm talking about information that's more explicit, and it's just directional information. And so think of the frictionless, pool table with the kinetic balls bouncing around. But think of it in terms of the balls all going the same speed and all having the same mass. So they're all identical, and they're all moving one speed. And so as they bounce around and bounce into each other, do this chaotic thing, there's no heat, there's no energy. They don't lose anything, they don't gain anything. All they exchange is directional information. And so you can sort of understand in different ways what the consequence of that might be. In the sense, let's say if you put it in a fixed environment, I'll use a circle. It's not fair to this. Atoms are going to be more complicated. But just say if you had something that bounced, say 1,000,000 reflections inside of a closed surface. What may happen is that every 1,000,000th bounce, it would repeat an exact line. So it would find the exact line it had gone once before, and now you have a repeating pattern. So even though it's 1,000,000 interactions, it's consistent in that it just keeps doing that over and over again. So now interject the idea that something from the external world comes in, also moving the same speed, all this other stuff, but it kinetically interacts. So it's coming in this direction. It interacts, changes this angle, so now the repeat is broken. There's a new pattern going to be created, and this angle will be created. Obviously this I'll make it bigger, but there's this triangle now that's been created with an angle, and that the angle here of this thing goes out, okay, at the same angle, the inverse of that angle. And so what has happened? Okay, something went in, something went out. So this is exactly equal. So, a plus went in and the plus came out here, a negative. Those two cancel out. No energy transfer. The only thing transferred is directional information and a pattern change. And the consequence of that pattern change, though, is that likely the effect of it's going to be is that it will migrate this entire pattern by this angle. So this whole pattern will likely move slightly in this direction. You could sort of understand that. The pattern has now been elevated to a new position. And if I drew this as a square, you'd see it even more obviously, perhaps, because you'd see the more obvious higher angle that it's reflecting at, and then now it's going to do the same reflecting, it's just going to do it at a higher position. There's probably some other way to draw it. But again, these are just, understand this is just a model of the idea of what goes in and what comes out, and that there's no transfer of energy, but there is a certain effect, and the certain effect has directional implications. I mean, that's what needs to be understood. And that there's no, understand again, as I've pointed out, when a school of fish is swimming in patterns, when they're swimming and swirling about, there's exactly the same amount of energy in that frozen school as there is when every fish swims in a straight line direction. So even though this 1,000,000 fish swimming in one direction looks highly energetic, it's exactly the same amount of energy theoretically if the fish are swimming at the same velocity. So if I release all the energy inside of an atom, it's like just converting all the fish into a fish moving in a single direction, and it's going to look like a hell of a lot of energy that you didn't see when you looked at the atom, because the atom was just sitting there. Because all the energy, all the movement was in many directions, and now all the movement's in one direction. So all the mass has essentially been converted to energy in one direction. Alright, well, I mean, I've already done that, but So anyway, this is what I mean by the kinetic Newtonian origins. This is the mechanics, I think, of physics. This is what physics is really doing. It is doing this discrete packets of directional information, and that's all that's really being transferred in the big picture of the system. And that all you're changing is the pattern of the movement of the matter. And when you change its pattern, you make it look like it has more energy. When it's coming at you, it looks more energetic than when it's going somewhere else, quite obviously. It's a little more scary when the bear's moving towards you than if the bear's spinning around in a circle eating grass or something, or berries, or whatever. Alright, so now let's get to this velocity idea. So I'm arguing that the function of this school of fish is how you really need to, it's an easy metaphor. So let's just metaphor an atom as a swirling of photons, things moving the speed of light, bits, particles trapped in patterns, swirling in a plasma. So let's just, for the sake of argument, let's just make it into a net structure of energy trapped in pattern. And now we're just going to talk about why would that packet of energy move, and what would be, what kind of dynamics could create some idea of it having a perpetual motion. So you could argue that gravity would create a perpetual motion in something, in the sense that as long as they had somewhere to go, you know, as long as there wasn't matter stopping them, like it stops us, we can't gain any acceleration because we're being stopped. But if we weren't being stopped, we would just go faster and faster and faster and faster and faster and faster and faster, until eventually we would just disintegrate into energy moving in one direction. So you could sort of understand that if you were in a perpetual gravity field that didn't have an end to it, that you would just start going, you know, your velocity would keep increasing by not only 15 feet per second, but if you got, if the gravity got stronger as you kept going forward through it, you know, it would be 15 feet, and then it would be 30 feet per second, and then 90 feet per second, and so your velocity would increase very rapidly, and your total velocity, because your acceleration every second would be adding more and more velocity. And that eventually, that would be like a school of fish going from swirling to going to each individual fish just turning into energy and moving in that direction. So if there was a gravitational field that broad or that wide, that expansive, it would just keep accelerating you until you disintegrated into energy. But in our world, we also have this idea of velocity in, say, the frictionless environment, us being a pool ball, us becoming a kinetic entity moving in space. But we're not really a pool ball. We're not really like the kinetic energy. Yes, we're floating in space, but we're a school of fish floating in space. We're still doing all this other kind of movement inside of us. And that's what's moving through space. And it's only going to move through space, or continue to move through space, if there's something about its pattern that compels it to move through space. So momentum isn't just, it's very simplistic to say, okay, something has mass, therefore it will just keep moving. Well, it keeps moving for a reason, because the shape, the pattern of the fish moves it. Fish don't move for no reason. Fish have to swim in a pattern that forces the movement of the school. So I'm just saying, when a school of fish moves, it doesn't move because its shape didn't change. It doesn't move because you push on it. It's a nebula. It's nebulous. You can't just poke it with your finger and say, move, fish. You somehow have to change the direction of the fish, so now they tend to go in a direction. They tend to spiral in that direction over time. The pattern repeats itself, but it repeats itself wrong, and therefore creates this idea of keeping the pattern moving forward. So there's a couple of ways that you might be able to shape that. So I'm going to just use metaphorical models. I'm going to use a description that's not a claim that this is how it looks. This is just how the dynamic whatever the real dynamic is, it's doing something similar to this. Okay, so it's just a similar model of the real thing, just because the real thing is kind of hard to dissect and diagram explicitly. So I'm just going to use an example of what it could be, what it could be like. So let's just say you have this nebula of an atom, and just metaphor it to a school of fish. And there'd be a point where all the fish are in balance. So the shape, if we use the shape as a description of balance, they're in a circle. You know, and they all kind of swim around, and there could be lots of different patterns that would maintain that shape and maintain that position. So now the fish just stay in one position because there's an equal balance of movements. They move in this direction as much as they move in this direction, as much as they move in that direction, as much as they move in this direction. So all the directions are equal in terms of the amount of time they spend moving in those directions. And as long as that's true, the school of fish will stay where it is. But what if I interject a piece of direction? You know, another fish goes in, he hits another one of these fish, he loses some of his direction, he changes his direction leaving, so he's gone in and gone out, so there's no more energy in the system, but he has changed the pattern of these fish slightly. And the question is now, how is that change converted into a permanent movement in terms of an increase in velocity? Because that's what gravity does to you. Gravity changes the patterns of the fish, so now it keeps moving. So it's almost like a school of fish in the sense that once they start moving, they just keep moving. You know, and then they can stop and start and do all that kind of stuff. But I'm just saying, it tends that the pattern just keeps them moving. They keep eating more seawater, and so as they eat more seawater, the school of fish moves, even though it's swirling. So it's the same idea as that. And so I'm just saying that there's a structure, there's a mechanism built into atoms that probably has something to do with shape. Okay, so because we're basically saying that there's a equal pressure from gravity from all sides, generally speaking equal. It might not be equal. There might be, in terms of this expansion idea, that there is some sort of left and right side that we can't see, but it does exist, and that we are subtly being accelerated more in one direction than we are in another direction. That our atoms have a tendency, a shape built into space itself that is creating the illusion of separation, everything moving away from each other. But anyway, I won't get into that because that gets kind of complicated. So let's just, for the sake of simplifying things, let's just call it an even pressure, and then we're going to say what happens when we introduce a change to the pattern of the atom. And so let's just say the atom starts off as a circle, and then something comes into it, a fish, a graviton. So we have a pressure change. So there was, 100 gravitons coming from this side, and there's 100 coming from this side. And then we put a little object here to block some of the fish coming this way. So now there's only 99 coming from this direction onto this object, and now there's 100 coming this way. So we have a net change of one fish. So this side is going to have one more fish changing its direction. What's going to happen is, the fish is going to go in, it's going to leave, losing some direction, changing direction by an angle, and it's going to affect one of these interior fish in the sense that one of these interior fish is now going to go from having that direction to having the straight line, the more forward direction. It could have this direction and be changed to a 45-degree direction, but it will just be a change. The change will be a fish in here will be changed in this direction going up, and a fish this way coming in is going to be changed in the direction going down. So they're just going to exchange directional information. So what would be a possible way to create that? Could it be happening? So I could argue that let's just suppose that when a extra graviton goes in, that the graviton really affects this external surface. So it goes right through this first surface, and it sticks to this second surface, and that's what creates the illusion of a change in its momentum. It essentially sticks a little here, and it pulls this out a little bit, flattens it out a little bit. So as it comes through, it pulls on this surface, this membrane, and by pulling on it, is tending over time to expand it, so that now all of a sudden we're creating an ellipse. And so if this kept happening, if an extra graviton every second kept going through here, every millionth of a second, every trillionth of a second, and one more extra fish kept coming in here, adding a little bit of directional information, pulling a little bit on that surface, it would tend to flatten this surface out. Okay? And that, what the hell happened to the, oh, complex pen? It has a light on it. Yeah, I should maybe turn the light, oh, you can't, the light isn't on the right end, and its battery's dead anyway. Never mind. So what's happening, so I'm saying is pulling on it this way. So what's happening is now you have the shape change being created by this little extra amount of gravity, gravitons coming from one side than the other side. And it's causing a flattening of this thing. So it almost looks like a paramecium. And this is kind of coincidental that a paramecium also has this effect of it, that it actually travels, its head is actually non-intuitive. It's flying, it goes forward butt first, essentially. Its mouth is actually on its sides, which even seems even less intuitive. That it would have a mouth that was, opposite of its direction. But that's sort of how it's built. So it really is kind of a strange little bug. But anyway, you get this ellipse, and what would be the consequence of that? Well, you could say, okay, it's nothing, it doesn't mean anything. But if I just do one thing to it, if I just create this idea of that it has a gap where there's a tiny little opening. Okay, so there's one little tiny opening in this ellipse. So there's just a little opening. If I do that and then I swirl this circumference, what would happen is it would just keep eating space in this flatter direction, because this is more distance. And you got to realize it's all the same speed. So if you think about this as the net, if you think of this as like a formula, this circle with an arrow, as a formula describing the net effect of all the movement inside the school of fish. So just think of it as a representation of this of the net directional momentum of the fish. Then what's really happening is it's now, because this side is flatter, it's traveling more distance, more time. It's spending more time up here doing on this side of its half than it is on this side of its half. If I did a straight line half, actually. Well, it's not really the half, it's the, okay, I got to think of the right way to say that. It's just, the idea is it spends more time on this side of the universe than it does on this side of the universe, if you could split this in half, or whatever the middle point would be of the circle, the gravitational center. Okay, so like with most ellipses, the center of the ellipse will not be the center of the circumference. It'll be the center. It just really, I'm not going to get into all that, because that's just going to get me confused. So the hell with it. But I'm just getting, you can get the idea that it's going to spend more time on this side of the universe eating space than it would spend on this side of the universe eating space, right? So when it's eating space here, this is the only time it's eating actual horizontal space, right? So it's a tiny amount of time where it's actually eating space in this direction. And this stuff is only a little bit in this direction. It's much weaker and much weaker. So as you get further down these sides, it's much weaker amount of space it's eating in this direction. Where here, it's eating much more angular space. So for every second it spends on this side of the orbit, it's eating a lot more space than for every second it spends on this side of the orbit. I guess that's a good way to explain it. So anyway, the net effect would be is that a graviton went in, changed the shape of the atomic wobble, let's call it, and in doing so oriented it to move in this direction perpetually. It will continue to move in this direction until you reshape this atom back into a round atom. So until you change this shape again, until more gravitons come in, say this way or some other way, to force a change, it will continue to move in this direction. So obviously an obvious way to force a change is to create an impediment, that it crashes into, and then that vibration, that opposite and equal reaction to a collision will travel right back through the atoms, and it will cause exactly the opposite effect in the sense that it will re-round, it will take that shape back off, because it will be the same as a graviton going in, as the forces are gravitationally tied to each other. So you have to think of this as a huge gravitational field, and this object is going to be part of the gravitational field, and in a sense, even though gravity won't have much of an impact between this hitting something firm or that it's non-transparent to it, that it can't travel through, this matter cannot travel through that matter, and there will be an impact, and there will be this equal and opposite reaction, which will be photonic pressure, photons moving through the matter in the opposite direction and causing the opposite effect of basically re-rounding the ellipse, taking away its tendency to move in this direction because it's now being reshaped by a bunch of photonic pressure reshaping these atoms. So I think that was a reasonable explanation. So again, it's just this idea of understanding it. If you just think of the atom being the first school of fish, so to speak, or even the electron, you could say the parts of the atom, whether you call them quarks or gluons or fermions, it doesn't matter what you call these parts, but these parts are the swirls, the captured photons, the ones captured in a pattern, and that they're all susceptible to these gravitons changing their internal dynamic, their shape, and then in turn changing their shape relationship to the other atoms. So what the next thing I'll explain, or the next subject I'll take care of, or work on, or add more hopefully useful information regarding what I'm trying to say, is the magnetic force. So this is basically explaining velocity and gravity. But what's holding atoms together, or holding atoms next to each other and maintaining shape dynamics between atoms, is the idea that they're in this gravitational field, but they're all, now they're not only exchanging directional information, right? Like with this, the graviton goes in, but there's going to be two flavors of graviton. An A graviton and a B graviton, and they will shoot out. An A will go in and a B will come out. That kind of thing is going to take place, and the A matter will be immune to B gravitons, so B gravitons will go straight through, and only A gravitons will be converted into B gravitons. And so by having that change, you can sort of get the indication that there would be a real change in the dynamic, in the sense that more gravity would travel through a substance in certain directions, and that if two opposite materials would be creating gravitons that were invisible to each other. So another object here, that say only absorbed B gravitons and produced A gravitons that went through A gravitons. So this object is allowing 100% of the gravitons through that this object that are transparent to this object. So it's like there's absolutely, that the pressure would be complete in one direction, and okay, well, I should save it because it is it's not very complicated, but it's hard to explain it, without really good, like, different colored chalk or something. That's what I guess I sort of need, just to get the idea of it, because you have to kind of understand that this is, okay, this is a B and this is an A, okay, and then you have to understand that only A's are going all the way through and only B's are getting bent. So A's are going through, B's are getting bent. Here only B's are getting through and A's are getting bent. Okay, so here's the dynamic. So here a bunch of A's are going out, both of these. This one's only letting through B's. This one's only letting through A's. A's are transparent to B's, so they go right through the B. And B's are transparent to A's, so they go right through the A. So now there's no pressure here, no gravity, so there's a 100% block, let's say, of the gravitons coming through here, in the sense that once they've been converted into B's, they're invisible. So there's lots of A gravity still moving from out here, pushing, or let's call it B gravity, right? And so there's obviously a force would be created because the B is creating a 100% block of gravity, and the A still has all this real gravity behind it, and so it's going to get pushed right into the B. And likewise for the B, because it's got the opposite transparency. So yeah, I think that's a reasonable explanation. I think you can sort of, if you have some understanding of, magnetism, I think you'll understand what I'm saying there. The idea that the attractive force is because they're creating things that's invisible to each other, and the repulsive force is that the exact inverse would happen, where this would be creating a doubling of the external pressure, in a sense, because of the conversion, and that so they would have the opposite effect of doubling gravity on the other side. So they would be maximizing the impact of the external pressure on one side and minimizing it on the other side. And that's why when you inverted them north to south, they would be pulled towards each other, because you're maximizing the external pressure and minimizing the internal pressure. And then when they're same as each other, you're maximizing the amount of gravity they're both transparent to from the external world, and maximizing a kind of, they're creating the the very thing that this one is susceptible to is being created by the other one. So the A gravity would be shooting at something with an A gravity, and so that would have a maximum effect because it's getting more A gravity thrown at it. You get it? I think you can understand that. Alright, so anyway, I didn't want to get too complicated, but that's what I just want to make sure that this was understood, that this is why the Lesage theory works, is because it's a exchange of directional information. There is no exchange of energy, because the pool balls are all the same and they all move the same speed. You can't change their speed. You can only change their direction. That's what the whole universe is made out of. The whole universe is made out of little bits, and the little bits have a constant speed and a constant mass, so to speak, for the sake of argument, of a unit of 1 mass. And they can't do anything else but change each other's direction. There can never be an addition of energy into the system. They never die, they're never created, and they're never destroyed. And that's the kinetics of the fundamental universe. It's all Newtonian kinetics. And the appearance of something more complicated than that is just an appearance, based on the fact that you've got to understand that you're not seeing the fish. That the first atom is already a school of fish, and then a collection of a molecule is a collection of schools of fish. So you're not seeing the fish, you're seeing the school behavior, and the school behavior is completely controlled by the kinetic circumstance, but you don't see it. You just see the swirl of the fish, and you see the slow movement of the school of the fish, and you don't see the fact that all the fish are still moving the same speed inside, and that all they've done is change direction. Yeah, that's pretty good. Good enough, I think. Yeah. Alright, so we'll call it a video. Till next time.